My name is Digdish. In today's session, we would study about what is a frame of reference and what are the different types of the frame of reference. So first of all, we have to know about how to find the position of a particle in any coordinate system. So we know that it has some value in the x coordinate, it has some value in the y coordinate. So the position of that point can be represented by x value and y value. So in that example, we can say that is the 4 centimeter and 4 centimeter. Similarly, if we consider another frame, so we are observing from different point. So here the position of the particle is different. So we say, it is at a 6 centimeter from the origin along x-axis, and same thing, it is at a distance 6 centimeter along y-axis. The point is lying at 6 centimeters. So it means that we are observing that point from different frame. What is a frame of reference? Frame of reference is a coordinate system relative to which the position and motion of an object may be described. To find the position of the particle, we generally use the frame of reference. Let us take an example. Consider a bus is moving with a uniform velocity, say 30 km per hour, along a straight line on the road. An observer who is sitting inside the bus and another observer is standing on the road. So that observer is at rest. Imagine a dog is running inside the bus with a speed of 5 km per hour. Now, how the dog motion appears for an observer A and observer B. For an observer A who is sitting inside the bus, for him the dog speed is 5 km per hour only. For an observer who is observing this event from the platform or from the bus stand, who is at rest, for him the dog velocity is not 5 km per hour. So for him it includes the bus velocity also. The bus is moving with a velocity 30 km per hour and dog is moving with a velocity 5 km per hour in the same direction. So in such cases, the dog velocity is 35 km per hour for an observer B. The same event is observing from both the frame of reference is different. That is, in the moving frame and rest frames, both are relative to each other. Now let us take a second example. Consider a train is moving along a straight line. If a person throws a ball upwards, its trajectory will be the straight vertical line itself. But for an observer who is on the platform, the ball takes a parabolic path. Here, both rest frame and moving frames are relative to each other. Now we define what is a frame of reference. The frame of reference is a coordinate system relative to which the position and motion of an object may be described. Here we can take, there are a number of coordinate systems. So there is a Cartesian coordinate system, spherical coordinate system, cylindrical coordinate system or polar coordinate system. For simplicity, we are taking only the Cartesian coordinate system. The every point in the space can be represented as x, y, z axis. Now we can write the position vector of a point relative to the origin, that is r is equal to xi plus yj and zk. In the rest frame, we consider only the 3 coordinate is enough, but in moving frame the time has to be measured in a different scale and the time is required to know the position of a moving particle. We need to know the time also. Then we must assign one more coordinate system, one more coordinate to the system, that is t. That is the time. The reference frame, such a reference frame is called the space-time coordinates, so which has the four components, that is x, y, z and t. This is space-time coordinate. Here there are two types of frame of reference, generally we say. The first one is the inertial frame of reference and second one is non-inertial frame of reference. First we have to study about what is inertial frame of reference. What does inertia means? So from our earlier classes, so we have studied about what is the Newton first law of motion, what is Newton's second law of motion and what is Newton's third law of motion. So here what is inertia and what does the first law says? Every body is said to be in its state of rest. So until acted upon by some external force, or when a body is said to be in motion until it is acted upon by an external force. So it means that we need some external force for a body to change its position or to change the direction. A body is said to be at rest until we apply a force. After applying a force only that body will move. So that is the first law says. It is the property of a material body which is incapable of changing its position is called inertia. Now, what is inertial frame? So whenever we are applying a force to a body, so then the body displaces its position. It means the frame of reference which is either at rest or moves in uniform velocity is an inertial frame of reference. A frame which obeys the Newton laws of motion is called inertial frame of reference or Galilean frame of reference or Newtonian frame of reference. So all the things are same. Here the Newton first law explains about the inertia, that's why we call it as Newtonian frame of reference. So before Newton, the Galileo explained this concept. So we have this, we can say that is a Galilean frame of reference. Here in inertial frame of reference, so what is the Newton's second law says? That is F is equal to ma. That is the force is equal to mass into acceleration. In this case, there is no change in velocity occurs. It means there is no acceleration. It is a non-accelerating frame. If the force applied on the body is 0, then acceleration will be 0, not mass. It has a mass. It has inertial property. So this inertial frame is also known as the non-accelerating frame. So this can be applied to rotating frame also. So here it is also known as non-rotating frame of reference. So one important question is, Earth is an inertial frame or not? Yes. We know that the Earth is revolving around the Sun in elliptical orbit. So it is continuously is in motion with a change in its velocity. And its speed is also very less. So if we take, the Sun is also moving, galaxy is also moving, Earth is also moving. So we are inside the Earth. Suppose a car is moving on the Earth's surface. So it is moving with a 30 km per hour. But we know the centripetal acceleration. of the earth is 3.4 meter per second square. So it is moving with a certain velocity. But so we are not adding that velocity to the car velocity. So we are observing that event from the earth itself. Here, for example, if we toss a coin, it comes back in a vertical direction. It will not take parabolic path for an observer who is observing from opposite side, because the earth motion is very slow. So we are neglecting the earth motion. We are not considering the speed of the earth into account. So the earth is an inertial frame of reference. Now we have to study about the non-inertial frame of reference. What is non-inertial frame of reference? A frame of reference which does not obey the Newton laws of motion is called the non-inertial frame of reference. Here, the frame of reference which undergoes an acceleration with respect to the inertial frame, so is called the non-inertial frame. What it means? So here, the body is not moving with a constant velocity. A body which could be traveling along a straight line, or it could be traveling along a curved path. So here, that is not moving with a constant velocity. It may be speeding up or slowing down its motion. In such cases, the Newton laws of motions are not valid. Why? Why it is not valid? The Newton laws is applicable to all the cases where we apply the external force on that body. A problem started in the Newton's second law of motion. What the Newton's second law of motion says? That is F is equal to ma. The force applied on the body is F, and acceleration produced by the body is A. Here, the F is equal to ma, it depends on the observer. Whether the observer is in the rest frame or in the moving frame, that decides the F is equal to ma. If we are in a moving frame, or we are not moving with a constant velocity, if we have an acceleration, so in such cases we are in the non-inertial frame of reference. So in such cases, the Newton first law or the second law is not applicable. That is, F is not equal to ma. Then what happens to that formula? If the observer is in the rest frame or is in the moving frame, or if he is moving with a constant velocity, in such cases, the force applied on the body, if we apply the force on the body is equal to 0, then the acceleration produced by the body is also equal to 0. But, so in the non-inertial frame of reference, we are not applying any force to that body, but still there is an acceleration. The F is equal to 0, but acceleration is not equal to 0. Here, the Newton's second law of motion is not valid in case of a non-inertial frame of reference. So we have considered so many experiments by considering the earth is an inertial frame of reference only. Because earth is moving with a constant, it is not moving with a constant velocity, it has an acceleration. Now, we are neglecting all the velocities of the earth, sun, solar system, galaxies, everything. We are neglecting everything, and only we are considering, so we are standing on the rest frame. That is, earth is not moving at all. So we are on the rest frame and we are observing all the events and we are conducting all the experiments. So we have performed so many experiments in the laboratory. So in that, so we have conducted one simple pendulum experiment also. Here, so same experiment, so we are conducting in a moving train. Now just imagine the train is moving in a particular direction. This simple pendulum experiment is conducting and the upper end is tied to the string and the other end of the string is tied to the bob. If the train is moving in a particular direction, then the bob starts moving in the opposite direction. We are not applied any force to that bob, but still it has an acceleration. This force is, there is no any force, it is not actually the force exists, but it appears to exist in the non-inertial frame. Then how to give the equation for this? That is F is equal to ma only, but with negative sign. That force is called pseudo force or fictitious force. A pseudo force or a fictitious force which does not exist, but it appears to exist in the non-inertial frame of reference. Here, why we are getting the negative sign in that equation is the force is imaginary force, but we have an acceleration and that pseudo force. So train is moving in that direction, it has an acceleration along that direction, so but the bob is moving opposite to that direction in which the train is moving. So that's why, so we have taken this as F is equal to minus ma. So we can take so many examples in the non-inertial frame of reference itself. So while taking a turn in a vehicle, sudden start or stop of a car or any vehicle, so we can observe the acceleration. In such cases, the Newton laws of motion, that is the F is equal to ma, is not applicable. A pseudo force exists, so which does not exist itself. There is no any physical force. It is not a physical force. It is imaginary force. It is acting. It is acting in the non-inertial frame of reference. The same situations we can observe in a moving lift. Suppose imagine the lift is moving upwards. So we can same experiment if we conducted in the simple pendulum experiment. So in the lift also, if we observe from outside the lift or inside the lift, the values will be different. To make the Newton laws of motions are valid, so we have to use the pseudo force. That is F is equal to minus ma. So this is in case of translational motion. What happens in case of a rotating frame of reference? In the rotating frame of reference, so we are not considering this pseudo force, so it is Coriolis force. An apparent force which arises because of the earth spinning around its own axis. So that effect is called the Coriolis effect. That force is called the Coriolis force. Freely moving objects are deflected to the right of their directions of motions in the northern hemisphere and to the left of their direction of motions in the southern hemisphere. So because of this, so we can get the tidal winds, cyclones. So if we drop any objects from the top or from far distance, so it takes a parabolic path, it is not moving in a vertical direction. So all these are examples for Coriolis effect. So we are not going into detail about this. So we can derive the Coriolis force also, but so we are not going into the details. We have studied about inertial frame and non-inertial frame of reference. In next session, so we would study about the Galilean transformation. What is Galilean transformation equations and how to derive that? So we have to see in next session. Thank you. Thank you all.